83% of Americans are right-handed. We randomly choose 10 Americans and want to find the probability of selecting exactly X right-handed Americans. Okay, so now we're choosing 10 Americans. We want to find the probability of choosing X right-handed. So the values for X, your random variable X, could be 0, 1, 2, 3, 4, all the way up to 10. Okay, so if we want to find the probability that all are right-handed, well, if all of them are right-handed, think about what has to happen. Every single one of them must be right-handed. So that's just straightforward, the multiplication rule. 83% chance for each draw, so 0.83 to the 10th is 0.1552. So there's almost a 15.5% chance that if you choose 10 Americans, that they would all be right-handed. Okay, now what about the probability that exactly 2 are right-handed? Well, now this is a little bit more difficult because we need to think about what would have to happen to get exactly 2 right-handed. Well, what can happen is the first 2 could be right-handed, and then the last 8 could be left-handed. But that's not the only way to get exactly 2 right-handed. You could also get the first one right, the second one left, the third one right, and then the last 7 left-handed. Okay, you could also get right, left, left, right, and then the last 6 left-handed. And we could keep on going with that pattern, but we can see there are a lot of possibilities or a lot of ways or sequences to get exactly 2 right-handed. Now, we don't want to list all those out. That's going to be your entire Saturday listing all those out. Okay, so we're going to look at how can we actually find the number of sequences without listing them out. Okay, so again, we see the calculations in part A, a straightforward application of the multiplication rule. So that's just multiplying right-handed and right-handed and right-handed is 0.83 to the 10th. However, the calculation in part B will be a bit more complex. First, we need to understand how we can get exactly 2 right-handed Americans if we randomly choose 10 Americans. The number of sequences that have 2 right-handed Americans out of 10 total Americans can be used finding combinations. Okay, and the way we do that using combinations, there is a formula for it, which I'm not going to go through the actual formula. I'm going to show you on the calculator. You can look up in a textbook or online what the actual formula is to find the number of sequences. What I'm going to show you is the calculator steps. So here, we are choosing 10 people, and we want to find the probability that exactly 2 are right. So what we're looking for is how many sequences can we arrange 2 R's and 8 left's, or 8 L's. Okay, so what we're going to enter is, we're going to press 10, and then go to Math, over to PRB, choose NCR, C meaning combination, and then enter 2 in. The way we write it is 10C2. So we have 10 people. We want to choose 2 successes. And we end up getting 45. So I'll go through the steps with you here. Okay, so we put in the number of people that we're choosing, 10. And then we go to Math, over to PRB. And then NCR means a combination of n things taken R at a time. We're going to look at it as n is 10. So out of 10 people, we want to choose 2 successes. So we choose NCR and then enter the number of successes you want to. And then press enter and it gives you 45. Okay, if we chose, suppose we were choosing 10 Americans and we want to find how many ways can you arrange 4 right-handed people. We would do 10, Math, over to PRB, choose NCR, and then enter 4 in, and that'll give us 210. So what that's saying is, if we wanted to arrange 4 R's and 6 L's, there are 210 of these sequences that we would list out. And again, that's a good way to ruin your weekend. Okay, so you can use your calculator to find the number of sequences. And remember, the idea behind finding that number of sequences is that each of those sequences will now have the same probability of happening, but now there's 45 of them. So you have to multiply whatever the probability of getting that sequence is times 45. And that'll be the total probability of getting exactly 2 right-handed. Okay, so after we find the number of ways or sequences, 45 of them, that we can get 2 right-handed Americans out of 10, we need to find the probability of each sequence. So here's a few of the sequences, and if we wanted to find the probability of each, well, again, we could get 2 R's and then 8 L's. We could get R, L, R, and then 7 L's, and so on. But what we'll notice is each of those sequences has the same probability. It's 0.83 to the second times 0.17 to the eighth. Okay, so if we do 0.83 squared times 0.17 to the eighth, we get this very small number. And I want to show you on the calculator, you end up with 4.8056 and then e minus 7. That e minus 7 is scientific notation for times 10 to the negative 7. And what that means is you move your decimal point to the left 7 places. So to the left 1, we'll put it to the left of 4, and then you need 6 zeros before you put your decimal point. So you can see that's a very small probability for just one of these sequences happening. But remember, we have 45 of those sequences that have the same probability. So to find the total probability of getting exactly 2 right-handed when you randomly choose 10, you have to multiply that probability by 45. So P of 2, so the probability of x equaling 2, is 45 times 0.83 squared times 0.17 to the eighth. And you'll see that you still get a pretty small answer, but it's a little larger than just the 1 sequence. Okay, so it's still approximately 0. And what's happening here is, again, because the probability of a right-handed person is 0.83 anytime you choose one person, you would expect to have more right-handed people than left. So only getting 2 right-handed people is not very likely. Okay, so what we can do now is come up with a binomial formula of getting x successes in n trials. So in this case, we had 2 successes in 10 trials. So in our case, x was 2 successes in 10 trials. Okay, so what we can do is you have to look at, well, where does the number of sequences come from? So the 45 here, that came from 10 people choosing 2 successes. So instead of using 10C2, in general, it's NCX. Okay, so we have NCX. And then you multiply that by the probability of success, which is P, to the 2. In our case, we're saying that's x for the general formula. So P to the x times the complement, or the probability of failure, which is 1 minus P. And here's the trickiest part of it, is the exponent on 1 minus P. Well, we see here that it's 8 for our example. Well, 10 subtract 2 will give you the 8. So if you take n minus x, that'll give you 2. So in general, it's n minus x. So for our example, to find the probability of exactly 2 right-handed people, out of 10, you want to choose 2 successes, 0.83 to the second. So the probability of success is 0.83, and you want 2 of them. And then you look at probability of failure is 0.17, and you need 8 of those. Okay, another way to look at the exponents is they have to add to the number of people that you chose, your n value. Okay, so how would you find choosing exactly 7 right-handed people? Well, P of 7, we still have 10 people. We're going to choose 7 successes. The probability of success is still 0.83, but now how many of those do we want? We want 7 of those. Probability of failure is still 0.17. If we have 7 successes, we have to have 3 failures. Okay, so that's the binomial formula for finding exactly x successes in n trials.